All right, imagine you have a set of magnets sitting randomly on a table, all pointing in different directions. Now, ask yourself, what would happen if we cooled this chaotic pile down to near absolute zero? Would they ever settle into a perfect order? Turns out, the answer is, shockingly no. And the reason why reveals something amazing about the very nature of complexity in our universe. Hi there. If you're new here, welcome to Hyperfocus. And to those of you coming back again, wow, your curiosity is what fuels this channel. I'm Olympia, and I'm more than a little obsessed with the way science lets us peer into hidden truths. So grab something cozy, because what we're diving into today might just add a new layer to how you see the world. Let's talk about spin glass physics, one of the wildest, most puzzling topics in modern science. Ready? Let's go. So, first things first. What the heck is a spin glass? It's not a fancy dish or something you'd serve wine in. No, in physics, we're talking about a state of matter that's as quirky as it sounds. Picture this. Take a material made up of magnetic atoms. In a normal magnet, all the spins, or quantum orientations of the atoms, point in the same direction. Think like soldiers standing in a perfect parade line. But in a spin glass, those spins aren't perfectly aligned. In fact, they're frustrated. Yes, scientifically frustrated. Some spins point up, others point down, and due to their chaotic interactions, they can't decide on a simple order. Imagine organizing a group of people who each insist on sitting next to their least favorite person no matter what. Result? Nobody's happy. That's a spin glass. There's no clear pattern to the madness. But wait, why should you care about this weird, conflicted material? Well, spin glasses aren't just an interesting quirk in the lab. They're a perfect case study for understanding complexity itself. These systems mimic real-world problems like traffic flow, neural networks, and even financial markets. Ever wondered why the stock market seems so unpredictable? Or how your brain forms memories through tangled, interconnected neurons? Spin glasses give us a clue. They're mathematical gold mines, helping researchers model how disordered systems function, whether it's magnets or an overcrowded freeway. Spooky, right? Now, if you're like me, you're probably saying, okay, that's cool, but can you explain why these frustrated little spins behave this way? Glad you asked. At the heart of this conundrum lies energy. In physics, systems tend to settle into the lowest energy state. They find the most comfortable, stable arrangement possible. But in spin glasses, competing interactions between atoms mean there's no single lowest energy configuration. It's like trying to solve a puzzle where the pieces constantly reshape themselves. No matter what, it's never truly solved. Scientists call this frustration, and it leads to something extraordinary, a nearly infinite number of microstates where the spins get stuck, like insects in amber. Mind blown yet? But let's up the stakes, because here's where things get even weirder. Spin glasses don't just reside in textbooks or isolated labs. Their principles echo throughout the universe. For instance, the same math behind spin glass theory also helps physicists tackle problems like protein folding, figuring out the tangled, three-dimensional structure of a protein molecule. Mess up the fold, and you could be looking at diseases like Alzheimer's. Suddenly, spin glasses don't feel so distant, do they? Let's add one more sprinkle of intrigue. Spin glass physics even intersects with quantum mechanics. Some researchers are probing whether quantum effects, those spooky phenomena that govern the tiniest building blocks of reality, could make spin glasses even stranger. Is quantum frustration a thing? Imagine future quantum computers tackling problems as fiendishly complex as the ones spin glasses exemplify. Now that's a sci-fi future I want to see. All right, let's zoom out. So far, we've covered how spin glasses are magnetically frustrated systems, how this frustration plays into larger models of complexity, and how they're helping solve enormous problems like protein shaping and quantum computing. From something so chaotic and elusive, scientists are teasing out connections to some of the greatest mysteries in the cosmos. So here's my takeaway. The universe loves complexity. Systems like spin glasses may look messy and unsolvable, but in that mess lies incredible beauty, a blueprint for understanding everything from your smart brain to the vast cosmos. And if you think about it, isn't that kind of comforting? Even chaos can lead to clarity. If you enjoyed this exploration, don't forget to hit like, subscribe, and leave a comment. What's your favorite example of complexity in nature or technology? I'd love to know. This channel is still growing, and your support means the world. Stay hyper-focused, and remember, sometimes, even frustration holds the key to cosmic brilliance. Ensure the expanded voiceover is even more entertaining, but that it maintains the same style, tone, and key points as the original.